Algebra 1. This is section 9.4, the addition or subtraction method. We are going to refer to this as the elimination method. And you'll see why in a minute. Some sources also refer to it as linear combination. They all mean the same thing. So if you're looking this up later, it might be called the elimination method, linear combination. Our book calls it the addition or subtraction method. This is the third way that you can solve a system of linear equations. So the first way was that you could graph the two equations and you could look for the point of intersection, and that point of intersection would be your solution. In the second method, we looked at substitution. When you take one equation that's already solved for one of the variables and you plug it into another equation in place of that variable. So if we had this system x equals 2y plus 3 and x plus 3y equals 4, because this one is already in x equals form, we could substitute that in place of the x in the other equation to solve. So those are the first two methods, the graphing method and the substitution method. Today we're going to look at the elimination method. This is my favorite method, and I think once you get the hang of it, you're going to like this one too. It tends to be nice and quick, especially once you get a lot of good practice. So we're going to solve using elimination. Remember, in your book, it will say solve using the addition or subtraction method. That's quite a mouthful, so I'm just going to shorten that to elimination. So let's say we have the system x plus y equals 14 and x minus y equals 4. So we're looking at this system of equations. We want to add or subtract the equations so that one of the variables cancels out or is eliminated, hence the elimination method for the name. So we're looking at the options here. If we add these two equations, x plus x would be 2x, y plus negative y will cancel out. That's what we want. We want one of the variables to cancel out. So for these two, the way they are already set up, they work well for addition. So we're going to add the equations together. All right, so if we add the equations, x plus x gives me 2x, y plus negative y cancels out. So then we have 14 plus 4, which gives us 18. This gives us a nice simple equation, 2x equals 18. We're going to divide both sides by 2, and x equals 9. So just like with other systems of equations, once you find one of the values, you need to go back to your original equations to find the other value. You can choose either equation to plug this 9 back into. So you can plug it back into this one or this one. It's up to you. I'm going to use the first one, so I'm going to replace the x with 9. So 9 plus y equals 14. Now I'm solving for y. I'm going to subtract 9 from both sides. So y equals 5. So your solution for a system of equations should always be an ordered pair. We put the x value first and then the y value. Now you could check this. If you plug these back into the equations, it should be true in both equations. So if I put in, remember this was x and this was y. So if I go back to this first equation, 9 plus 5 equals 14. That's true. If I try the second equation, 9 minus 5 equals 4. That's also true. So this solution is true. It satisfies both of those equations. Okay, let's try another. If we have 3a plus 2b equals 2, and 3a plus b equals 7. So we're looking at this system. We want to add or subtract the equations so that one of the variables will cancel out. So if we do 3a plus 3a, that gives us 6a. 2b plus b gives us 3b. Nothing canceled out. If we subtract 3a minus 3a, that's going to cancel out. Then 2b minus b will give us 1b. So that's what we're going to do. We're going to use subtraction. So we're going to subtract. I would prefer that you rewrite this. So we've got 3a plus 2b equals 2. When you subtract, all of the signs are going to change. You're subtracting all the way through the equation. So this is going to become negative 3a. This is going to become negative b, and this is going to become negative 7 because we're subtracting each piece. So 3a minus a cancels. 2b minus b is 1b, and 2 minus 7 gives me negative 5. So my b value is negative 5. Then I need the a value, so I'm going to go back to one of the original equations, plug in my b value. You can choose whichever one you want. I'm going to choose the second one. So I have 3a plus b, so plus negative 5, equals 7. The opposite of negative 5 is positive 5, so I'm going to add 5 to both sides. 3a equals 12. Divide by 3, and a equals 4. Now, when you write your solution, if you don't have x and y, you want to put your ordered pair in alphabetical order. So since we're working with a and b, the a value goes first, and the b value goes second. So if they give you letters other than x and y, you want to put your letters in alphabetical order. Again, you can check that if you go back to the original equation and plug in 4 for a and negative 5 for b. It should check in the first equation, and it should also check in the second equation. It has to check in both in order to be a true solution. Let's try a couple more. This first day, these are pretty simple, so I think you'll find you're getting through these pretty quickly. If we have negative 3n plus 9m equals 6, and 3n plus 4m equals 7. So this is our system. We're going to choose if we are going to add or subtract. So if you look at these two right away, if you add these two equations, the negative 3n and the positive 3n are going to cancel. So we're going to add these two. Negative 3n plus 3n cancels. 9m plus 4m gives me 13m. 6 plus 7 gives me 13. So I'm going to divide both sides by 13. 13 divided by 13 gives me 1. So my m value is 1. Now I need to figure out n, so you can go back to either equation. I'm going to choose the second one. So we have 3n plus 4 times 1 equals 7, because our m value is 1. 3n plus 4 equals 7. Subtract 4. 3n equals 3. Divide by 3, n equals 1. So our solution, again, we're going to use alphabetical order. So m first, then n. In this case, you wouldn't really be able to tell because they're both 1. So we have the point 1, 1. If we had done the graphing method for this one, these two equations would have crossed each other at this point 1, 1. If we had done the substitution method, we also would have gotten the same solution, 1, 1. So all three methods are valid. You could use the graphing method or the substitution method or the elimination method. They'll all give you the same solution. Sometimes you just need to look at the equations they give you and decide which method would be the easiest or the fastest, or which one do I prefer or feel the most comfortable with. Sometimes you just get to choose. For your test for me on this section, I will probably ask you to demonstrate that you know how to use each method. So I might have 2 questions where it says solve using the graphing method, and then 2 questions that say solve using substitution. I'll be looking at your process and your solution. And then I would say for the last 2, solve these using the elimination method. So again, I'm looking at your process and your solution. All right, one more. If we have 8q plus 12r equals 20, and 5q plus 12r equals -1. So this is our system. We need to choose if we want to add those 2 equations together or subtract. So if you're looking, 8 plus 5 is going to be 13. 12 plus 12 is going to be 24. Nothing cancels. So let's try subtracting. 8 minus 5 is 3. 12 minus 12 cancels. So that's what we want to do. For this one, we're going to subtract. Again, I highly recommend rewriting it to avoid any kind of sign errors. So all the signs will change in the second equation. So we're going to have -5q minus 12r equals +1. So once you change all the signs, then you're going to be adding the equation. So 8q minus 5q gives me 3q. 12r minus 12r cancels. 20 plus 1 is 21. So I called it subtraction, but once I changed all the signs, it's actually addition. Then we're going to divide both sides by 3. 21 divided by 3 gives me 7. That's my first solution. Now I'm going to go back to one of the original equations. I'm just going to use the first one. It doesn't matter which one you choose. We have 8 times 7 plus 12r equals 20. So 56 plus 12r equals 20. I'm going to subtract 56 from each side. 12r equals -36. Divide by 12, and r equals -3. So again, if you're not using x and y, you want to do alphabetical order. So we would have q and then r. So 7, -3. Again, you could check it by going back to the original. It has to be true in the first equation and the second equation in order for it to be a solution. So now we've looked at 3 different ways to solve systems of equations. In our next lesson, we're also going to be using the elimination method, but sometimes we're going to have to do an extra step before we can add or subtract the equations in order to get what we want to cancel out. So we will be looking at that in the next lesson. In the meantime, hopefully you will enjoy practicing the elimination method. I think it's pretty fun because it goes so fast.